Okay, cool.
But if you want to get ready, yeah. Hello, everyone. Hello. Echo. Okay, guys. Anyone on Slack, please go to the stream just to validate it. Seems like something's happening. Someone's watching it already.
You are live.
Okay, great. Okay, so everyone, welcome to yet another edition of Explore's pop-up classes. This time you don't have to listen to my boring voice. We've had Musi, who's taken quite a few of these. This is on the official channel, and it's being broadcast to everyone in Cape Town, so hey to everyone in Cape Town. Today we are looking at PySpark again. Once, as I've said in previous pop-ups, PySpark rears its head whenever your data set isn't trivial in size anymore, and you have to do quite a lot of processing on it. So even if you aren't doing it in your current internship projects, you will use it one day in industry, and it's a good thing to have a wrap on it. So we have Daniel and Martin who are going to be helping present this. I don't know, are you guys going to be standing together, or are you taking different sections?
We'll be jumping in and out.
Whatever's happening, they're hot swapping. Like all pop-up classes, please interrogate them as much as possible. We're having problems with the mic, hence there was a delay in starting up. So your voice won't be picked up here, so just be loud and as clear as possible when you ask a question. Don't be embarrassed to just put out any questions, and I think we'll run from there. But without further ado, guys, you're going to have to be doing what I always do, and that's looking over your shoulder. And
no problem.
Yeah, start with everything.
Right, yeah. Cool. Cool. So, welcome everybody.
When you're done, you
Yeah.
can just hit the stop streaming.
Stop checking. Okay, awesome. Cool. So for those of you who don't know me, I'm Daniel, and I'm going to be doing the introduction section of this little pop-up class, and then showing you how to get some basics going with data frame creation and a couple of other things, and then Martin and I will be hot swapping out for the individual tasks. So I'm going to start with a gentle introduction to PySpark and the world of distributed computing. So one of the biggest questions that people get in the industry is, what do I do if I have a data set that's just too big to work in a local environment, right? So all of us have had experience with working with AWS instances where, you have an S3 bucket that's loaded, but even then, oftentimes you still can't load the whole thing into memory, and you have to, chunk or use various other modules to try and figure out the problem. So Spark is the answer to this. But before we get into the answer, let's talk about Spark itself for a little bit. So this is basically what we're going to be covering today, but we'll go through it. Right, so PySpark is a great language for performing exploratory data analysis at scale, building machine learning pipelines, as well as creating ETLs for specific data platform usage. So everybody here by now should already be familiar with languages like pandas, so modules like pandas, and the languages used to do basic data manipulations. So the goal of this class is to get you guys up and running with PySpark in a very simple local instance that you can work and play with and figure out how to do things before we move on in later classes to showing you how to work with it at a larger scale in Databricks, where it's a bit more complicated and where things get hectic. So the first thing you guys should know is PySpark is like Python and Spark got together and had a baby, and out popped PySpark. So that's what this lovely little image over there is showing. So the key thing to remember about this is, just like the key to pandas is the pandas data frame. The key to Spark is the Spark data frame. So this can be thought of as a table, just like it would be in pandas, but that's distributed across an entire cluster. So one row might be stored here, another row might be stored there, but we'll get to explaining the specifics of that just now. So the other thing that is also good to know, it is still possible to use pandas functions in PySpark. You just have to load the pandas data frame into the memory of the cluster, and I will go into why you might not want to do that in some instances, or when it can be useful to do that. So the biggest difference between pandas and Spark data frames is quite simply that Spark performs lazy execution. So for those of you who don't know what that is, lazy execution is just Spark builds up a graph of all of the different transformations, all of the different things that you're doing to the data. So I'm changing this data from string format to date time. I'm then adding 3 columns. I'm then dropping this column. I'm then timesing this column by 100. I'm then percenting this column, and it adds like what's called a node graph of all of these different transformations. So it builds a framework that tells Spark what to do, but it hasn't actually executed any of those commands. It's just built up what's going to be done. The second you then call something like display in Spark, it executes all of those commands and prints your output. So what this allows us to do is save on both CPU and memory usage, because you're not reading that entire data set into memory. So a good way of looking at this is comparing these two diagrams. So the diagram on the bottom here is what would happen in a typical kind of pandas environment. So you read your file from the storage, be that on local or on a cluster. It goes into job 1. As soon as job 1 is finished, it writes it out into memory. Then you have job 2, which reads it from memory, writes it to memory, and so on and so on and so on and so on. And so what happens there is your computer slowly uses more and more and more and more and more memory until things crash, and you can no longer do because out of memory. Sorry, can't help. Now, what happens with Spark is it does it differently. It reads from the local stable storage to job 1, then writes back to a partition within that local storage space. Then reads from that particular partition, executes job 2, and then writes to another separate partition. So what's happening is you're having multiple jobs performed on a single operation, which speeds up how fast things happen, and also avoids the over-memory usage. But that'll become a little bit clearer as I move on to do some more explaining. So this PySpark data frame comes in the form of what's called a resilient distributed data set, or RDDs. So what exactly is an RDD? Well, there's a very, very nice diagram. You'll see I love diagrams. I'm a visual learner, so I prefer pictures to words. So you can see here, right? So these are our different data frames present in our PySpark environment. And what essentially an RDD is it's a bunch of data that's stored in different partitions across whatever storage is available in the local cluster. So if you have an AWS, this would obviously be in your S3 bucket. If you're using Databricks, this will be on whatever Azure service you've linked up to that. Now, why this is so important is because whenever you execute your command, the command is executed across these separate partitions with a job for each partition, which means you can get the computational crunch done a lot faster than you would by running each of these jobs individually on one CPU at one time and then having to pass the results back and then run the next on the next. It all runs parallel and then links up at the end. And so this feeds into another very, very important feature of RDDs. And so this is why RDDs are so much better than standard data frames. So in-memory computations, because you aren't having to do the whole read, write cycle from memory, it speeds up the performance by an order of magnitude. It allows lazy evaluation, so it allows PySpark to build that node graph that I spoke about earlier for all of the operations that are going to be performed, and then only execute them when it's necessary, so you're not always executing them. It's super fault tolerant, so if you think back to that previous diagram, that partitioning process happens many times over many different locations in the cluster. So if one of those partitions suddenly goes missing because you have a random bit flip, it's fine. The data frame will just go, oh, well, it's missing in this location, but I have another copy of it here, so it's fine. It can rebuild, so it's tolerant to faults. RDDs are completely immutable. They're not like pandas data frames in the sense that in a pandas data frame, if you want to change a column's values, you can change a column's values. In this, you literally have to overwrite the column that was originally there. So it's very much, if any of you are familiar with working on Linux or any of the file systems there, it's very much the same kind of idea where you can't change something, you have to literally overwrite that entire thing with a new function in order to get anything in. It partitions the data frame into many separate pieces, which ensures, once again, that it is completely fault tolerant. It's persistent, and it allows the application of coarse-grained operations, which just means the operations can be performed on a very fine scale and can be tuned to do very specific things, and can be applied to all elements in a data set through using maps and filters. So you still get the same functionality as you would with pandas and your ability to group by and filter and select for certain things, but without the added computational cost of having to run through every single thing in the data frame. Any questions so far? Awesome. Everybody on the same page.
Question.
Yes.
The whole story of partitioning.
Yes.
Is it like maybe if there's 10 partitions, does it take the data and just divide it into 10, or how does it work?
So it depends very much on how your environment is set up. So for instance, the one we'll be showing you today, it sets up the partitions somewhere on your local hard drive. So it's a space that it allocates on the local hard drive. If you're on a big server system, it can do it multiple ways. It can allocate it to a particular storage location. It can allocate bits of it across all of the storage locations. And the partitioning, you don't have to specify the number of partitions that it... Yes?
No, I was just going to add in there. So, yeah, depending on use case, so Spark internally, remember PySpark is an instruction for the Spark program that essentially sits across the cluster. And there are a number of ways where it will choose how RDDs are distributed. It looks at things like latency. So as Daniel was saying, for larger servers, we might find actual substantial latency from one node to another. Just say it's like on AWS and these aren't co-located in the same building. Then it makes more sense to have RDDs situated in nodes that can communicate faster to one another. But it'll also take other metrics into account. You can define how many RDD partitions you want for a given data source, but Spark will try and tune it to A, a robust number of partitions, and B, one that will allow for computation to occur the fastest. So it's really, often you shouldn't be defining it yourself, and with Spark you often try and let the program do as much as possible, and that's the whole philosophy behind those lazy valuations here. That essentially, you aren't telling Spark when to do an operation, how to do it. You're letting the program decide that because it will often do a far better job, an optimized job compared to you deciding how many partitions are made or how many, how to execute various jobs where.
Cool. Any other questions? Right. So moving on. So how do we create these wonderful PySpark data frames? So there are a number of data formats you can use to get data into PySpark. So you can read in CSVs, you can read in JSONs, you can use XML data, you can use Parquet, which is a file type that's quite heavily used within Spark in general. And and you can obviously create an RDD manually. So I'm quickly going to show you just the basics, and this notebook, I will put this notebook up afterwards. The only thing that you guys will have to do in order to get this to work is to install PySpark via Anaconda, and then all of this code should run straight. So whenever you're working in Spark, the first thing to do is...
Sorry, Daniel.
Yes.
Do people need to install Spark?
No. So you do not need to install Spark, because installing Spark on Windows is, trust me, you don't want to go there. You really don't want to go there. It is not a fun process. So you literally just need to go and you can just type into Google installing PySpark on Anaconda, and it'll literally just give you a conda install that installs it, and you'll be able to run this. So no, you do not need to install Spark, the big package, onto Windows. So whenever you start a Spark session, or whenever you want to use Spark, there are certain things that you need to do in order to get Spark to work. So this import little thing here, right, you can see I'm importing pandas because we're going to be using pandas to show the difference and comparisons between how you would do something in pandas and how you do it in Spark. I'm then importing PySpark, and then the next line is super, super important. So from PySpark, import Spark context. So the Spark engine on your computer needs you to point it to the location where it's going to be doing all of the functions. So that's what the Spark context does. And you see I set the Spark context as SC. I'm just importing a few things here that we'll use, which is row and SQL context. Row is used for, I'll explain later, but row is used for when you need to create a data frame manually when you're inputting data. And then SQL context is just to allow us to use standard SQL commands in order to query, create, select, edit data frames. And then I'm importing the SQL basic functions as funct, so that we can use some of the base built-in functions. And then finally, I'm calling the Spark context at the bottom, that SQL context. I'm now executing the Spark context within the SQL context that I imported earlier. So that's just going to allow all of the modules that we need to function properly. So we can have a discussion afterwards, because there are other ways of doing this. You can institute a Spark session as opposed to a Spark context. So there are multiple ways of doing this, and sometimes you may want to use sessions as opposed to using context, but I find context works a lot better if you're going to be doing a lot of different things. It seems to cover most of the bases for most of the functions you will be using. So this is just quite a simple, how do we create these RDDs? So I quite simply just read in a list. So it's just a plain old list. So I've got some names and I've got some ages, and then you call the Spark context parallelize function, which is essentially going to allow Spark to interpret the Python list into an RDD format. I then apply a map function where I am mapping my row, so 0 in all of these to name and 1 to age. So that's just providing me with the column names. And then I define my data frame people within the Spark SQL context, and I create the data frame from that map lambda. So essentially, to break down in simpler terms, what's happening there is I create a list. I'm using parallelize to put that list in a format that Spark can understand to read in to a data frame, because Spark doesn't have the same data structure as Pandas does. And then I am applying a lambda to give it what those columns must be called, and then finally reading that into the Spark data frame that we can see. Where's my mouse? Why lost it?
Yeah, so just in terms of more context as well, where that sc.parallelize function is being called, that's essentially, as Daniel said, it's translating a Python list into an RDD. You have to just run the context above it.
I was like, wait, I just explained that I had to run that. So as you can see, one thing you will notice is Spark does run quite slowly within Jupyter Notebooks, because it's designed to run on a much bigger platform. So you will have to wait a little bit longer than you would for some of your normal Pandas stuff to work.
And also, if you ever want to have manual control of the number of partitions, and in some cases you do, So you want to determine like the number of partitions used for each of your RDBs can greatly influence how long certain jobs take to do. If you have too many partitions, it can reduce the efficiency of computing different stages. So in that parallelized call, there's additional arguments where you could say, I want to have 20 partitions or 100 partitions, leaving a blank or auto-tune. So Spark will determine how many partitions need to be created. And you'll probably find in this instance, even if you have a cluster, with a list that's small, we'll only have 2 or 3 partitions created. It won't fill up an entire cluster. Your data won't go everywhere.
Yeah, so now we're going to move on to a few of the other ways that you can load it in. So I'm not going to discuss loading from JSON and XML because that's not what we work with most of the time. I'm going to focus on what we do work with most of the time, which is CSVs. So I'm just going to show you the example. So in Pandas, it's quite simple. We just go data frame and we read in. And now in Spark, it works a tad differently. And you can see I'm going to import Spark files, which is basically the module that allows access to reading file types. Once again, call the context because it needs to know what's going to happen. And then df PySpark, once again, SQL context because that's the context we're using for all of our data because we're going to want to use SQL commands later on to filter it. And then I point it to sales CSV, header true, and infer schema. Now we'll have a discussion about that now because you're going to see something pretty interesting. So I'll just let this run. So that's run fine. Now let's have a look. So just like you would in Pandas, if you want to see, you'd use df.info, right, to have a look at what columns you have. In PySpark, you're going to go df PySpark print schema, which is basically going to show you the schema, which is PySpark's way of showing you exactly how the data is structured and what types of data are present. Right here. So, just look at that. And so this data, to give you a bit of context, is sales of sunglasses or glasses and glass frames over a time period. And is there something wrong with this? Who can pick up the problem here?
Everything's a string.
Yeah, exactly. So quantity, sales price, average cost, should those be strings? No, they shouldn't be. They should be numbers. So a thing that's very important about Spark when you're importing things is up here, I said I'd come back to this. Infer schema, we chose false. So Spark is just going to load everything in as a string. It goes, this is default. You haven't told me exactly what to do here. I'm just going to load everything in as a string because it's easy. So you want to be careful with that because that can throw you off. So what you should be doing is you should be executing the exact same command just with infer schema equaling true, and now you will see the magic happen. And all of a sudden, voila, we have things looking like they should. So, yes?
What do we do if it infers incorrectly? So it assigns an integer value to something that should be a float, for example?
So if that happens, you can use PySpark's built-in type functions to change the type to whatever type you need. We will discuss that later when we change a string to a date time. So you can just look up on PySpark's wiki. They have a whole list of functions. I don't have them here now of how to change a string into an int or yes.
You said earlier that we're importing the SQL context so that we can use SQL commands. So can't you just cast in SQL?
So that is actually one of the ways to do it.
Yes, you can also do that.
Yeah.
So yeah,
people are quite good with how to do everything on this on PySpark. That's Stack Overflow, definitely a big friend, and PySpark's thing online. There's documentation till the cows come home, so like you won't be lost.
But yeah, so you can, if you're comfortable with using the cast function. I'm not comfortable with that in SQL. I prefer to do it in a pandas oriented way, but yes, you can totally use that. And so you'll see a few weird things here. So you'll see integer and double. So double just means that's Spark's way of saying it's a decimal number. And Spark stores those decimals for however many decimals there are for that number. So You can also change that double into a single and then specify exactly how many digits you want. So that's Spark's way of rounding, which is a bit confusing, but once again, that will be explained a little bit later. Yes?
Where's the info on the index? About the index, as in what type of index it's using?
So index as in the location of each of these.
Yeah, like for instance, in pandas,
Yes.
it gives you information about all your columns, but it also tells you the type of index that you have. Like
Yes.
which index type of a deal.
So with this, it doesn't do that because Spark doesn't store the data like a pandas data frame. It's not stored in one location. So how you would view that, you'll see later on when I show you the display, it will come up with the indexed rows. So this is just showing you an overview of the data frame in terms of the schema, which is the types of data. When we get to this display, you'll see it then sorts the data into in instance a nice human readable format. So if we just go down to say now we wanted to do just a basic thing like in pandas where we want to read in the top 5 rows, we can do that. How many of you can read that? Let's rather put the question as how many of you can make sense of that? So once again, this is not the best way of printing out data. If you do want to print out a particular row to have a look at, you can use it, but it's not really the best way of doing it. So the best way of doing this is using the show command. With truncate set to false, the only reason we set truncate set to false is because if you set truncate to true, it takes full column names and it squishes them onto multiple lines, which makes the data frame look horrible to view. So this is the best way to have a human readable, and you can see there we now have a very nice breakdown of exactly what's going, and now you can begin to see it's now indexed everything correctly. So like it would in a pandas data frame, it's just not showing that index column.
So the only thing I want to know is like quarter 1, 2, and 3, and 4 are kind of like sets underneath.
Yes.
Is there
It does that.
It does that, and the reason it does that is because this is in a Jupyter Notebooks. So there is only so much reach it has here, and you'll see when we show you the display function, it gives you a slide bar at the bottom, and it will show everything correctly. So there is a better way of doing this.
But also when you're done and you actually want to put it into pandas or whatever, just start to pandas, we'll show you later.
Yeah. So this is just some basic things. So in a pandas data frame, you'd often want to look for the shape, see how many rows, see how many columns are present. So it's just simple as df pandas.shape. In PySpark, it's a little bit more complicated. You need to count the length, and then you need to count the number of columns present. So this basically here is what this command is doing. So we're getting the string of df PySpark.count plus the string of the length of the PySpark columns, which is basically going to tell us this is a count of how many rows are in the data frame, and this is a count of how many columns are in the data frame. And then you put that together, and you get something that looks exactly like a pandas shape command. So I am now going to hand over to Martin to take over for this, some basic data frame manipulations.
Hi everyone, so for people who don't know me, I'm Martin, and some of you might be wondering why are we actually doing all of this and where did we find this time. So a lot of it was kill 2 birds with 1 stone, that our data set that we're working with, it's 13 gigs, that doesn't fit into memory, that we couldn't do anything, and we needed to do feature importance and feature engineering till the cows come home, and it's just not possible in pandas. And learning a new language, how do you know that you're actually doing things correctly? So we would take small subsets and then do it in pandas, and then slowly but surely do it in PySpark to actually understand not only what's common, what syntax stays universal between using pandas and PySpark, and what actually what's different and what are the little tips and tricks that you need to look at. So this whole notebook is essentially laid out with, it says how it's done in pandas and then how it's done in PySpark. If you just want to compare the two, you don't have to run the commands, just see what's common, what's not common. The one thing that's very common between this is dots everywhere, method onto method onto method onto method. So if you're quite comfortable with that, I think this shouldn't be the worst thing you've seen today. But yeah, so so like with a lot of time when you actually import some kind of CSV and there's any kind of date format file, unless it's actually separated by hyphens, it's going to turn it into string. It doesn't know what to do with that. So like in this case, so we said cool, just normally like in pandas to date time, and there we go. That's how we do it in date time. But what do we do with PySpark? Well, PySpark, as Daniel was saying, can pretty much do most things that pandas can do, but it has a million functions you actually have to import to actually work with. If you try something online and it says that can't find this thing, more likely than not it's just a function you have to either install, very rarely install separately. It's usually hidden somewhere within PySpark, and just saying sometimes like from PySpark import this, and 9 out of 10 it works. So that's just something you should be wary of and start getting a bit more comfortable with. But that's about the biggest roadblock you'll hit. So you just import it, and then the way we would use so usually how we would do it in a pandas data frame is say your df, and then you give it the column equals like above, the way you would how you would reformat that date column. So in PySpark, what you have to do is you use the command with column. So with column, you can either create a new column or you rewrite the one you have currently. So you just provide it with sales date, and then you say to date, sales date, and then you give the format in which your data is in, and there we go. It's done it just like it is, and then it's in the format that you need it. So once you actually want to start looking into your data and actually getting familiar with it, aggregated functions and just general functions to tell you a little bit about your data set. In pandas, that stuff is like where pandas shines, that you just put methods on top of methods and you'll be a master of your data frame in no time. But PySpark, it's almost as easy to do as well. So the most common one is you want to find out the mean of a column. So let's say just give it the method. And in PySpark, what you just have to do is call the aggregated method, and then give it the column you want, and then the type of calculation you want. So you can replace mean with standard deviation, with median, with whatever you'd like in there. And then, so in this format, if you would say .show, it would essentially say average, sales price, and then and it will give you the value. But what if you actually want to use this calculation for something? You want to put it into either a variable and then put it later into a threshold, or everything above or below this mean, or whatever the use would be. You just say .collect, and then you say 0, 0 to get the physical location, to get that physical location of this information. Yes.
Yeah. So this is an example. We haven't seen much of it in the previous notebook, like prior to this notebook, but when you're calling .collect, that's essentially saying, okay, everywhere across the cluster, I want you to actually perform this aggregation, pull it to the driver node or the node that's going to be inspecting this data, and the 0, 0 is just because of the inherent form that arrives in Python.
Yeah.
Spark runs in Scala as a scripting language, and so it essentially has to go from Scala through the Java virtual machine into Python, and that's why there's that double tuple required, essentially.
Yeah. Yes.
So just to clarify, you said .show, it will create like a data frame.
So actually, I'll show you quickly how it might look.
Just hash out the document.
Yeah. Is that it? One more. Cool. So that's essentially how it looks. So that's just how it comes out. So if you actually just want to have a look at it, you can do it that way. But as I said, if you actually want to use it for any kind of calculation, doing it this way or saving it into a variable will give you problems. So this is the way you actually take it out. Yes.
What happens if you change those zeros after the collect?
So it essentially, so I'll show you how it looks. If memory serves correctly, it looks exactly the same like that, doesn't it? Yeah.
It's going to be nested inside of 2 and 2. Right?
Yeah. So it looks like that. So then when you say, then you just need to do the 0, 0 to get it as the physical value itself.
Because it's located within a row, within a column. So you can put in
row 0 index.
Row 0 in column 0, I want that value.
Yeah.
From there, please.
Yeah. So now, cool. Yeah. Is there a question? Cool.
Question.
Yeah.
What if you want your aggregated function? What if you want to have a customized one? And you're not just looking for a mean or using something.
So a lot of it they have that stuff ready, but actually so maybe we'll do another thing like this on actually using UDFs.
Yeah, so that's in the next one.
Yeah, so UDFs are actually, essentially it's a wrapper it's almost like Spark's version of apply, that you can write your own custom functions and put it within a UDF, and then give the UDF to PySpark. And it's just like a dot apply or a dot map with your custom function or with your custom aggregates. And then, so that's how you would do something like that.
So what I've had before is instead of taking the mean of data, you can apply a convolutional neural network to a data directly in a UDF. So it's a very powerful abstraction. You can kind of do
just the neural network.
A word of caution on using UDFs. If for instance, you want to use the mean, it's a lot faster to use PySpark's built-in mean function than to write your own mean function. So if there is a PySpark aggregate function for what you want, use that one because it will perform a lot better. Custom UDFs can sometimes take quite a bit of time to
Ages.
run and even simple ones can sometimes take quite a long time to run. So just keep the time constraints in the back of your mind. So if it is not present, then yeah, sure, write your own one. But if Spark does have a version of it, rather find that and use Spark's one.
Yeah, and on that note, I think Daniel and Martin are saying they want to do a follow-up to this about machine learning.
Yes.
And so you don't have to call a neural network in a UDF. Spark and TensorFlow have quite a close collaboration, so there's a lot of support for just training via high-level APIs. You don't have to, as I was saying, literally pass a network in as a UDF. There's a lot more functionality there now.
So now, sure, just running everything one by one. You can do that, but like we do in pandas, let's say we want to know almost everything about a column. We just say the column we want and dot describe. There you go. And PySpark, pretty simple as well. So all you do is when you want to subset just one column, like in SQL, you just say select or dot select, and you say the columns you want. So you can essentially just give as many columns as you want to a select, and it just chooses those. Then you just, as with pandas, say dot describe and then dot show, and then you get essentially you get your whole summary statistic. That I haven't used it yet, but I assume you can also do a dot collect and whatever.
You can also do a dot collect to pull out specific values.
Yeah.
And also in the dot describe, you can add some custom arguments in there if you want to. For instance, if you want to do the quartiles or you want to do the interquartile range, you can do all of that in the summary statistics as well. So it's quite expandable.
Yeah. So as I said, with one column, it's nice, but what if you want to do the whole data frame? Pandas, you just say dot describe and it's got your back. But luckily PySpark also has your back. So you just say the whole thing dot describe, and then since it's a mess when it's in PySpark, if you actually want to see it as a pandas data frame again, you just say dot to pandas, and it converts it to a pandas data frame straight away. This is the main thing. What Daniel was saying, that you run everything you need, every transformation you need on your data, and once you actually have your final data representation ready, and you know you have enough RAM available, then you say dot to pandas, and then you're sorted. Then you're on your way.
Yeah, and sorry, just to clarify, that's enough RAM on the machine that will receive the result.
Yes.
You don't have to worry about RAM in the cluster.
No.
Yeah.
So use a word caution, use two pandas very sparingly.
I agree.
Because if you have a large data set, every time you call two pandas, you're using up resources. And so if you are doing visualizations and you're doing 4 different visualizations, you're taking however much data and you're using up 4 times that amount of storage. So yeah, use it very sparingly, try and get as much as you can done before you actually have to call the two pandas.
So also the one problem with that is if you run out of memory on a Spark session, you have to restart the whole thing from scratch, because we've dealt with this too many times. After a while, your eye immediately finds memory runs out. So yeah, if you do everything, so literally plan out everything nicely. Just keep doing a .show to preview your data, and once you're ready, then you can do it to pandas, and that'll save you a lot of heartache. Not even in the long run, almost immediately. Yeah.
Is there a way to check how much memory it's going to take to run that two pandas command?
Ooh, I actually don't know. That's a good question. Do you know, Daniel?
Yes, there's a command that you can check. I'm not 100% sure exactly what it is. I've used it once or twice, that you can check the size of the Spark data frame when it's inloaded into memory.
Cool.
I will go and add that as a comment when we post the notebook up.
It's important to note that PySpark is quite approachable, but like most tools, the more you get to use it, the more complex it is. There's a lot of subtlety that's like just hidden from you when you start using it. It's a nice API at a high level. At a lower level, there are things like you actually can define how much RAM the driver process inherits. So, and also when those RDDs are being executed, you don't ever really see with newer Spark versions the RDDs themselves, but you define how large those are. So there's various properties that will define, like when you call .2 pandas, what really comes out of that, and these limitations. So don't worry about it until your program throws an error, and then it tells you about it. Like as Martin's alluded to, unfortunately with Spark, it's horrendous to debug. It's very complex. It actually, Spark has its own little dashboard that it gives you just to debug your program. Because it often crashes, and if it crashes, it's not just crashed in your local computer, an error has happened somewhere in the cluster. One of the nodes has a computation that fails, and so it's trying to start somewhere else. And you need an entire dashboard just to know what's going on. It's like an interactive debugger.
You almost start developing like a special skill for finding where on earth in your error message the actual error is, because it'll shoot out a dump about this long, and then you don't know where on earth the problem was, but sometimes you'll find either some columns, it'll say something about a type. If it says memory, very often it says something about memory, or it says something's wrong type or whatever, but yeah.
Yeah, and that's, once again, it's because, so Spark is actually hosted in a JVM, so the Java virtual machine, which is running Scala code, so, or raw Java, depending on how the implementation is. And so when it gets to Python, essentially you've got your Python code, but also Java, debugger console information there. So that's why it becomes such a long output. And the solution there is just learn Java, because then you'll be able to read the Java errors, Python errors. Yeah, it's simple.
Cool. Yeah, so that's how you would do describe. Now, as with a lot of things that we do, we want to actually maybe calculate something, that you want to know the difference between the actual sales price and the stock price or market price. I don't know, or I'm not sure how this data set is set up.
Ask Rita, he kindly provided us the data.
Nice. Or what was it? All the main idea is, as with pandas, we always are making new columns, new calculations. that do row by row, just row by row calculations. And as I was saying, that usually we put the column we want to work on there equals and your calculation. And in what was it? So there we go. There's the results. But in PySpark, as I was saying, that one of your biggest friends will be the with column. So just like in that case, you say df.PySpark with column, and then you give your price difference. That's the column name, and then so here's the func.round. So you don't have to round it. Once it's a type double, it carries on for ages. I'm not sure how many decimal places. I think it's 9 or 10. That looks messy, so you can just put the round, but you can actually skip that and just say df. Just like on pandas, you say your data frame, the column you want, and minus the column you want as well. And here we go. And very similar, a little bit different, but pretty much still nothing too different from what we're used to with pandas. So now just some simple aggregations. We do group bys. We essentially do group bys almost all the time, no matter what we're doing. And depending on your question, how you want to do feature engineering, you can just group by. We just put our group by thing. Yeah, what's up?
Just wanted to let you know, like that X price X thing.
Yes.
Is excluding tax, so it's not a price.
Oh, okay.
So it just is
How much? Okay, so we just calculated how much tax you put on. Okay,
Yeah.
cool, nice. Okay, yeah. So then in just standard how you do it in pandas, just a group by. You provide your columns that you want to group by, and then we want it to count, so you can do your count. That PySpark pretty much does it almost exactly the same, but unlike with pandas, if I didn't provide any column here, it would have given you the entire data frame. That in PySpark, essentially what you ask for is what you get. So because you want to just supplier, brand, and category, you got supplier, brand, and category, and their counts. Then another thing that I use this a lot, just getting to know what specifically categorical columns, our trusty value counts. And that was actually one of the things that I was the most sad about, that there wasn't any kind of direct value counts equivalent. But just messing around with PySpark, I found that you can just leverage group by to essentially do the same thing. So all you would do is just make your value count variable, you do your group by, and then of course you want the highest count at the top, so you just order it, so you just do a quick order by. Just like SQL, what you'll learn very quickly in PySpark is the more you use it, there'll just be SQL words that pop out, and if you're running something and you can't figure it out or you're trying to apply Python or Pandas logic to a problem, just try and translate it to how you would do it in SQL, and 9 out of 10 it'll work. That I didn't know how to find distincts or how to find uniques. So I kept running unique, and it kept saying no, there's no such thing as unique. And then when I Googled it, like, yeah, distinct, there you go. So that's how you would do your value counts.
Yeah, so just one thing. If you look at the documentation, you'll see that you can use the .order by, but you can also give a fully qualified SQL statement as well. So you can interact with it as though it's a direct database call.
Yeah.
So that'll be in the documentation.
Yeah, so that's actually the one thing that you'll realize quickly, is that it's a very interesting hybrid of Python and SQL and all of that. That if you can't figure out how to do something in PySpark, or how you would technically do it in Pandas, just throw a select statement into there, and 9 out of 10 will also work. So it's nice that it gives you multiple ways to actually solve the same problem. So let's say we actually want to subset. So we just subset, we want to get every value where the brand is Prada. There we go. That's how you would do it in Pandas. And with PySpark, like with SQL, rather than doing any kind of subsets, you can just give a where, and it'll give the same result. Like Jonathan was saying, it's built on Scala, so from what I understand, that Scala rather than where has filter, and this function actually does the same thing as the where. So unlike with pandas, you actually have more than one option of how to do your subsetting here, but life isn't always easy that you don't always just want to subset by one thing. So what if you want to subset by two things? So we want to know where the brand is Prada and where Q3 was equal to 1. So we do that in pandas, nice and simple. But then when we actually compare the PySpark to the pandas statement, you can start seeing where the similarities come in. So you just put your .where, and then you wrap each individual subset in your parenthesis, and you separate with an and just like that it works. And also, just in case you guys are wondering, it also works the same with filter. There we go. What if you actually want to filter on time ranges? Well, pretty much the exact same way you would do it in the above examples. That's how you would do it in pandas. You give it your two statements. There we go. And then essentially you would do it the same way in PySpark. So there's that. So there's how to do that. So what if you actually want to do some sort of differences? So so the question I asked was, what if you want to understand the difference between the prices in terms of the Prada item sold at Luxottica? So we make a small subset of our data where the supplier is Luxottica and the brand is Prada. You order by your dates or by your date column, and then you just do a .diff and you save it to a new column called price diff. Should have named this a little bit better, but it's fine. So then you'll see you have your differences there. So PySpark, once again, we'll make a separate one, just like a diff test, and then do our subset. And then here's where a little bit of the differences start coming in. That what you're actually going to have to do is you do a thing called the window. So it's essentially you give it a range or some sort of form. It's a form of how the data how it should apply something to the data. So the way you just import window, and then you first just have to create your window. So you just say window equals window order by sales date. So essentially it just takes it takes the data you give it, and then it turns your sales date into a window, but orders it first. So I'll show another example of how you can add even more functionality on top of that. So unfortunately, unless you're doing dates, if you're gonna do a comparison like this with the diff, you're gonna have to make a lag column. So you just say df lag, and then you make a new column called the previous day's price. You call your function lag, and then you just say df your sales price column, and then you say over window. And essentially what that ends up doing is adding one more column, but just taking the previous day's data right next to it. So you can just minus one from the other, and then you'll have your difference. And then essentially just say results, df.lag with column, you make your new column price diff, and then you just minus your sales price from the previous day's sales price. And then that's how you would do this. What if you actually want to see the number of days between these between certain transactions? Well, that's also possible, and not that hard in PySpark either. So the question is, what if you want to calculate the number of days between each transaction for each store? So you would just sort your data frame like in pandas, and then you just call a difference column, and then you do your group by and you apply. So you would group by your supplier and your sales date. So that's how you would do it, at least in pandas. And now I'll show you how you can combine window with lag and another operation on how to do this. So there's your result. And when you do it in PySpark, here's window again, but we also added an additional parameter called partition by. So we know that if we wanted to do it just in general, we didn't have to do that. But since we want to do it per supplier, we don't want it to take everything and shift everything over one. So even if you have if two different shops had a transaction on the same day, you don't want 1 day or 0 time or 0 days between a transaction. You want to do it per store, so that's where you give the supplier. Then the only difference between the previous one and this one is you don't have to make a lag column. That PySpark has a special function called dateDiff. And dateDiff just sorts this out for you. So you just say, you make a new column, say date passed, call the dateDiff function. You say what column you wanted to run this dateDiff on, and then you run this the lag function from above within this, and then you just say over window. Yes.
I'm sorry if this is a silly question, but that df PySpark that you created,
Yes.
is that a Spark data frame?
Yes.
And is it saved in local memory or is it across all?
No, it's distributed until yeah.
So all of those previous ones that you made, if you scroll up those previous, like every single step, you created basically a new data frame.
So if I add columns onto it, then it's essentially not really. It's just creating a new node in the in the whole system. So you have it's like you're saying, it's just a different data frame. It's technically the same data frame, but it's a new version of it over and over and over again.
And until you actually call like do pandas or something like that, it actually hasn't created it yet.
It hasn't done anything.
It's a dream of creating it, essentially. It dreams of one day becoming this.
So you can run as many df PySpark things as you want. It's not taking up any memory because it hasn't actually executed that. It's just a set of orders to create that data frame.
Yeah.
But then where does it save those? It has to save the orders somewhere, so surely it takes up some memory.
Well,
Those are the nodes, right?
yeah, it does, but it takes up very, 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 very little.
Yeah, when you define those functions, you're essentially telling the driver process, these are the sort of things I want to do. So it builds up a DAG, essentially. It's directed acyclic graph that will say, this is where we should start ordering our different computations. I've said before, the reason why it does it lazily though is because right at the end, you might specify an operation that is better to be done somewhere in the middle of getting your data frame than right at the end. And so it keeps on reshuffling that, and that's why you never see an actual physical form of it. It's Spark is thinking all the time, what is the most efficient way to lay out these things so that one day when I actually say df.PySpark or df.PySpark.show, I've got a good plan of how I'm going to get that data to you.
Yeah. So do you want to do some of this stuff or?
Yeah, sure.
Cool. Yeah, and then we can switch out again later.
Cool.
Maybe about 10 minutes, guys.
Oh, jeez. Okay.
Cool. We'll run through.
But there's not all that much left after this in any case.
Okay. Once again, just doing some basic adjustments here. So let's say that the price of a particular product, we've decided that it needs to increase by 5% because the stockists, haven't got supply, so we need to push it up a bit. So in pandas, that would be as simple as selecting the column that we want, selecting the brand or the string that we want to attach this to.
This is just showing the. Yeah. Oh, jeez.
We will have to finish this later.
There is a JD of 60.
Yes, well, we will post it.
We just have to figure out the algorithm that is time
But I mean, what's the answer of the
understand more about that, and I think with the notes as you go through
It just gives you that space to
it's really
Hi everyone, sorry, power delay this side, so we will have to resume this at another time. Power's back on. Alright guys, well power's back on.
Yeah, so you just need to wait for everything to come back again.
Yeah.
So there's a meeting now where we have to.
Yeah, there's no problem.
What's the name? Let you know what the.
Yes, please let me know. And if they want to give me a job, I want to usher. I don't want to be downstairs.
Why don't they just put everyone on stage one?
Okie dokie.
Stage 1. 2 hours. And just follow it.
Right.
You are on.
I can tell.
Nice. Is OBS working?
Let's double check.
Is the stream still on?
Yep, the stream's still working.
Nice.
Stream's still working.
Cool.
Everything's still fine.
Right. Yeah, just go up a little bit because
Yeah.
it went all the way to it. But
Okay, but this is probably a warning sign that we should wrap up.
Yeah.
I even ESCOM wants us to wrap up. Is it stuck?
Are you trying to listen to your...
I'm just checking that the audio is working. It's already past that.
Oh jeez. Nice and correct.
Aha.
There we go.
Uh-huh.
Nice. Where were we?
Where were we?
Oh, the adjusting thing, yeah.
Yeah. So in pandas we would just call it in and then adjust it according to the 2 columns and perform our basic operation there. And there we go. And then we'll be able to see that the price has shifted somewhat. By 5% of the total value of the product. And once again, with PySpark is always a little bit more wordy, a little bit more complicated. So once again, our favorite friend with column. And then we use this this function called when, which is the equivalent of pandas if else. So it's basically a conditional. So when X condition is met, do this. Or when X, Y, Z conditions are met, do this. If those conditions aren't met, do something else. So here we're just calling in. This is incredibly confusing.
I know. So what was it? So the whole
No,
thing-
like as in I can't see where the mouse is on the screen.
What I meant as well is, so you guys will see that it says condition beyond equals the function. So you don't actually need to call that. You can essentially put that func.call brand equals beyond into where beyond condition is. That's just the way to clean up the text a little bit.
Yeah. So basically there you could replace this condition beyond with a condition beyond up there as a way to clean up. And then you just apply the function to the particular column, what you want to do to that column. If it doesn't meet the condition, that's this otherwise tag, you're just gonna return the original sales price. So without the 5% added on.
And then since we're doing multiple columns, essentially you can just keep bolting on the with column.
So if you want to do multiple, you just chain multiple columns over and over and over and over and over. And then that is going to give us this lovely one. And if you go and check the top, it matches. So I think that's where we will wrap it up for today because of technical difficulties and all other wonderful things. I'm also running out of time. So we'll continue next time. We'll give you a little bit more on some other basic things, handling nulls, doing a few more advanced things, binarizing, fixing that, and then I will move on to doing some machine learning oriented stuff within the Databricks environment to give you an idea of the power of Databricks and its ability to do quick visualizations and quick EDA, as well as leveraging the power of Spark's built-in machine learning package called ML to be able to rapidly chain out models just like you would with scikit-learn in Pandas. So that will be up next time.
Yeah, so essentially it's that since we're all doing this anyway, that we might as well have this, and it's not only it's also the many pre-processing steps that we have to do, your feature vectorizer, your one-hot encoder, your string indexer, and all of those things. When you prep your data to put into a model or into some kind of algorithm on PySpark, it's similar, but it's also a bit unwieldy. So I think that also deserves to be on its own.
Yeah. So we'll give you guys in the next session some info on that. Awesome. Have fun. Hope you enjoyed.